everyone, and welcome to the AI Talk Show. I'm Asha Saxena, founder and CEO of World Leaders in Data and AI. We call it WLDA here. It's wonderful to have you all join our LinkedIn community where we actually engage with all of you to talk about real issues in data and AI. What I value most about our community is I feel that it is a lot more than just the world leaders, the WLDA community, but it's also the people who are in the data digital tech arena and care about what we are building. We bring together the senior leaders who are doing real structured work, especially in the enterprise arena of transformation. I think we've all gone through the data digital tech transformations, and now we're in the world of AI. We're not just focusing on experimenting anymore. It's really about building or rebuilding, I would say, the foundation to make sure that the AI can perform and the promise AI holds can come true. In this series, I think it allows us to bring really the leaders who are open to the conversation, and we can learn from them about what's happening in the complex, large organizations. And today's discussion is all about something that doesn't always get spotlight: infrastructure. And I'm really excited about that because I think infrastructure is really about the foundation. We all get excited about the AI outcome. We all constantly talking about co-pilots, agents, automation, but very few organizations are really asking deeper questions. And I would say the deeper questions is really about what kind of data architecture allows intelligence to scale safely. And and I would say also we want to make sure they're safe and sustainable. AI doesn't fail because of the models, and we hear about that all the time. We say it's a leadership failure. Is it truly about the foundation? But really, it is. It is. The AI models are fail because if the foundations are not strong, if the foundation is weak, and that's why I'm thrilled to be able to join by Dan Bennett, someone who has led enterprise data and technology organization through multiple industry shifts, from cloud to big data and today AI acceleration. Dan, I'm so excited to have you here. Welcome. And before we dive in, I would love for you to introduce yourself in your own words.
Well, thank you very much, Asha. And yes, hello, Dan Bennett, Head of Technology for the Enterprise Data Organization of S&P Global. I'm a roughly 30-year industry veteran, started out as a software engineer, actually graduated with computer science and AI from Leeds back in the day when AI was doing one of its winters. We're not in a winter anymore, that's clear. And I agree totally with your point, Asha, about the data foundations, the data infrastructure is so key to getting this right. So my role with S&P Global is really leading the technology in infrastructure, data strategy, to create those underpinnings, if you like, across all of the four divisions of S&P Global, and essentially create the standards, create the ecosystems, the platforms, the technologies that allow us to standardize how we bring data into the company, how we describe that data, and then how we distribute the data out to our customers and help them on their AI journeys. So that's my role in all of this, based in St. Paul, Minnesota, which is not an S&P location, but where I'm lived, but frequently in New York.
That's great. And welcome to our cold New York. We've
Yeah.
had some really cold days the last few weeks. And so, I'm fascinated by your journey of data. We talk about AI and we talk about all these agents and how fast these agents are moving forward, but rarely talk about data. So maybe we'll start with where you've had the front row seat to some of the most important infrastructure shifts in enterprise data. So if you think about, the data, the technology organization through cloud transformation, big data initiative, and now the AI wave, cloud changed deployment for us, big data changed scale for us, but AI feels a little different because now machines are not just sorting or processing the information, but they're also giving us a lot more. The conversation, the instant response, the instant search results with human-like feel, and so the promise becomes really big. The promise becomes really huge of the value, the efficiencies or innovation. So from your perspective, what feels fundamentally different in this moment compared to earlier waves of enterprise transformation? And especially when you look at the large enterprises today, what separates companies from structurally ready for AI from those who are still experimenting? So I think two questions here, you
Yeah.
know, historically and then moving to the current state.
Yeah. So it's a fascinating point you raise that like so much of this is the same, and we've had um, you mentioned big data. I did the whole Cloudera Hadoop journey. What was that? Over 10 years ago now. Um, and we spent a lot of time historically thinking about what technologies were we going to use to solve this? Prior to the Hadoop thing, a lot of companies were spending time with things like Teradata and other data warehousing technologies. And I think as technologists, we spent, a lot of our energy and enthusiasm, like, okay, how am I going to solve this technology problem? What am I going to do to answer questions quickly? But the fundamentals always stayed the same. We're going to create some kind of data warehouse, we're going to create some kind of data mart, we're going to write some SQL queries, we're going to deploy a BI tool, and each of those plays, as engineers, we were deeply involved in each of those. And yes, the technology's changed over time and the deployment cycles reduced over time. So, with a modern cloud data warehouse, you can be up and running far quicker than you can go and buy the infrastructure and deploy it yourselves. We all know that. So in some sense, that's just been an acceleration of everything that we were doing. Um, but what's always been interesting to me, and I think what's changed to your question, is if you truly want to deliver on that promise of AI being able to answer questions over this stuff, if you truly want that, that dream that everyone in the company can write a SQL query without having to know SQL, right? Which is
Yeah,
that's all of our focus right now is that
that's
how do
right.
you take natural language and convert it to SQL? And SQL is so powerful as a language. We can say
Yes.
so many things in it. It's not a trivial language to generate accurately. Um, my conclusion, and I think a lot of where the industry is going on this is we have to do a much better job with semantics. We have to do a much better job with describing the data. And that's because we want the AI to really truly understand what we have sitting in all of these tables that we're busy curating. And it's no longer sufficient for that to be tied up in a DBA's head or the BI developers head. We have to describe and externalize all of that knowledge. And that becomes the really interesting frontier for me is how do we go down that journey? And we've seen, the rise of the semantic layer. We saw the launch last year of OSI as a first attempt at standardization. Arguably, we've had standardization around semantics for 25 years, but they haven't made much progress in terms of industry awareness. So that's the big change for me. And I think what separates those who are getting some progress and some traction on this from those who are not is the ones who are externalizing that understanding, that knowledge of where their data is. It's all the classic data governance things that we're aware of.
Yeah.
Pick up the DAMA DMBOK, it's all in there, but did we do it in a way where AI can actually make sense of what we've done? That's the big change now.
I love your focus on describing data. I mean, the phrase that I think deserves more attention now is the AI ready metadata.
Right.
And at S&P Global recently, you have introduced the AI ready metadata across your
Yep.
marketplace.
Yep.
But on surface, metadata sounds technical, even administrative, more so. But in reality, it's the layer that tells machines what data means. And I think that's what you're talking about. It's
Yeah.
really having the models understand how it can be used, where it came from, and what problem were you really trying to solve with that, having that data together. I think what's broken in the old model of data discovery and consumption is really not having that clear definition. And so for leaders who are watching, and people here on the LinkedIn watching, why should they start thinking of metadata and not documentation, but as strategic infrastructure? Why do you think this is a critical initiative for organization, and why
Yeah.
was it a critical initiative for you as you think about creating this AI system that operates autonomously,
Yeah.
having the critical, right, lineage and so on. So maybe
Yeah.
share a little bit about your journey.
Yeah. So you're right. A lot of this information is tied up in documentation today. And we all know you can take a PDF and you can toss it to a RAG system, and an LLM will do a great job of interacting with that. Um, but there's a fundamental issue in my mind, and it's to do with this concept of determinism. So all of the modern LLM AI infrastructure we have out there is probabilistic in nature. And what we mean by that is it's using statistics, it's using these n-dimensional math to think about the world and model the world. And there's a certain amount of noise in how it answers. In fact, with most of them, you can turn the amount of noise, the heat up and down if you like. Now, that's all great. That's part of what makes them creative. It's what allows them to make these leaps across concepts. Um, but my central thesis in all of this is if that's the direction of travel, the more we can ground these probabilistic systems in truly deterministic, um, very clear logical statements about the way we've modeled the world in our enterprise,
Right.
the more accurate that LLM is going to be. So yes, the sort of probabilistic nature of LLMs is wonderful, but if we can inject some determinism into them, we can both have it rely on that, ground in that, and also use that to test some of its outputs. So what we did last summer was we said, look, we've got all this data we share with our customers. It's available via all the typical marketplaces you might expect. And we said, look, instead of asking a data engineer to download and consume a PDF or some other sort of documentation, let's find a way to connect the data directly to the metadata. And it always surprised me that that was never really solved for in relational systems, right? If you think about the data dictionary of a relational system, you've got the column name, you've got the column type, and typically there's a comment on the column, and typically the comment is empty. And so the central thesis here was let's use that comment if that's all we've got. If the database system like Snowflake, for example, supports tagging, if they support tagging, we'll use it, but most of these systems don't. We'll use that comment column, and what we'll do is we'll put a URL in there to a immutable permanent web page, which has all that machine readable metadata for that column. So it doesn't just say this column is called X. It has
Right.
the description in multiple languages. It has the order of magnitude. It has the unit of measurement. It has relationships to external ontologies if those exist. And the idea there is for customers is, okay, you can now, your AI or your data engineering pipeline can look at that data dictionary, see that list of URLs, go and retrieve all of that metadata, and then inject it into whatever your pipeline is. If you have a semantic layer you're building, put it into there. If you have a data catalog, put it into there, wherever it makes sense. But because that's all machine readable, because we're using formal semantics, using the RDF stack, which if you don't believe in that, you don't like it, that's fine. Just think of it
Right.
as name value pairs for that column. But because we're using all of that, we can be very deterministic about that information we provide to the AI. And it's important to remember as well, this pattern is
Yeah.
proven in the MCP space, right? So
Right.
we've seen MCP go from zero to industry standard, the USB of LLMs in what, 14 months?
Yeah.
And that's exactly what MCP is solving for. And it's saying, here, I'm going to deterministically describe an API. And LLM, this is the API, you choose which API you want, but now you've got enough metadata here to make that decision. So it's really the same approach as what's happening for MCP, but we recognize and it's quite clear that MCP doesn't solve every data integration use case. So
Hmm.
you need an approach that works for the bulk delivery of data, and that's what we're trying to solve for in a vendor neutral way, because the book isn't written on how we're going to solve this yet.
That's true. That's true. And I absolutely. And I think we are all entering this world with all these new models and trying to see what would work for us. But I think the most important thing that you touched upon, I mean, of course, I think having the metadata is important, but you touched upon interpretability a little bit. And I think there's an interesting shift that we are seeing around this interpretability. AI models are, increasingly, bringing this information together from multiple sources,
Mhm.
and across your organization, or it could be from other ecosystems. But I think the only thing that works is if there is a shared language,
Yes.
and when you think about how you spoke a little bit about the common identifier can improve interpretability across ecosystem. Do you see open identifiers becoming more foundational in digital infrastructure, maybe similar to domain names, how they
Yeah,
were enabled in the web?
yeah, absolutely. So that's another thing we launched to just get out of the way. We almost 3 years ago now, we launched our open data website,
Hmm.
and the thinking there is for those identifiers, it's for that reference data. So if you take a step back and you just think about the world in the most simplest form, the world of data in the most simplest form, there's facts, master data, and reference data. And some of this is in the eye of the beholder, right? You can absolutely have a great intellectual conversation about, is this piece of data master data or reference data?
Right.
That doesn't matter. You have everyone can have their view on that. But if you think about an information provider like ourselves, really all we're doing is selling facts. So the price of oil over a timeline or a time series of a price of oil, or the equity, the number of employees in a company, all of these things are facts, and typically they're all things that have a time series. But for those to be interpretable, you have to have a set of master and reference data to enable that interpretation. So if I tell you that the aggregate GDP of Northern Europe is X and it was Y in the quarter before, the month before, that's great, but you have to have an understanding of what we mean by Northern Europe. Is the UK part of that or not? This is a very sensitive topic for me, right? So those are questions ultimately of semantics. So what we're doing with our open data website, it's at dunl.org, dunl.org, is starting to share some of those semantics, some of that referential data, some of that master data as machine readable data. So those semantics are shared between producer and consumer. And we do that under a Creative Commons license because we want the customers' AI, or potential customers, future customers, past customers, doesn't matter. The point is you can bring that data down into your system and start binding that to your definitions. So if you have a definition of Northern Europe that aligns with ours, great, make the connection in your data. If your definition doesn't, then look at the constituent countries and figure out how to make the connection that way. So that's the philosophy there. Because again, it comes back to what we were talking about previously of, how do you make this data easier for AI to
Yeah.
consume? Well, you've got to be able to describe that reference data in a way that AI is not going to make guesses. And that's the fundamental point here, right? If I give you a table of data and the column name is state, there's 5 definitions of the word state in most Latin-based languages, including English. And the definition of your interpretation of the word state depends on your background. A scientist has a very different definition of the word state than a
Mhm.
politician. So we can have the AI guess, or we can provide that referential data and with that metadata, so the AI is not guessing. And fundamentally, that's the play here, to allow that accessibility. Um, it we could get there with the PDFs and documentation, but why not make it much easier for the AIs?
Right. Right. No, absolutely. I think you're talking about those important elements which I'm sure the listeners are struggling with too, is, building all these pieces that are required to build that infrastructure that we spoke about, just making sure that, how do you really bring this data and make it meaningful for these models to consume effectively?
Right.
But I want to kind of shift gears a little bit and I want to talk about the, right after ChatGPT came out and this whole natural language process explosion happened in 2023, and everybody was fascinated with Gen AI. We are living in a world where executives want AI outcomes quickly. They are asking, why are we not having productivity gains now, or automation or new product launch? But in the real world, uh, things, invisible things that we are talking about, the data architecture, the governance framework, standardization, making these internal cases for investing in infrastructure that may not show ROI immediately, but they're essential for long-term intelligence. Uh, and the we spoke about data definitions, but the data quality, that is a huge challenge, and now you have machines that are going to be consuming this data, not just humans. So how do you deal with, and how have you been able to really invest in the infrastructure? And we always say it starts with the executive leadership, and them to believe in building the strong foundation. But just for the audience, I think this is such an important conversation because everybody's in the race to show results.
Yeah. Yeah. Um, and this is always, I get asked this question by customers as well. And it's always a slightly nuanced answer because as an information provider, we don't produce any atoms, we only produce electrons
Yeah.
here at S&P Global. And so that data quality, that alignment of reference data, all those things, very much part of our DNA. And so those business cases tend to be supported much more by revenue, which isn't so much the case when you start talking with a customer, where data is really, it's something that it supports their operation of their business rather than it is their business. And so those arguments start to become more about cost saving, productivity, as you were talking about, and it's a navigation of that. For me, the progress that we've made is really, if you can come all the way back down to, and this as a data or technologist, right? This is always a challenge for us. We love to geek out on the technology.
Yes.
In my case, I love to geek out on the semantics, right? Business, those words don't mean a lot of sense, right? So really, the single biggest thing is to connect this to business value. And my boss, I've had many great bosses. My great boss right now, he's always reminding me to talk about business value, talk about business value, and he's absolutely right because that is so key to how you describe and get funding and make the case for these things. And so, talking about business value is what problem are we going to solve by doing X?
Right.
And a great example for us internally is um, within our divisions of S&P Global, you've got very tight alignment to deliver product within those, within that division. A lot of the data quality, a lot of the referential data issues all get solved within that division. But increasingly, as you operate as a single enterprise, you start to want to create products that span the divisions. And that immediately starts to create a little bit of a challenge of like, well, this division does this over here, this division does that over there. How are we going to align it? So the business value is we want to create a product that spans the two. The answer, the technology answer for us in that particular use case is let's use a knowledge graph.
Right.
So we're not going to load everything into the knowledge graph. We're not trying to map everything as a graph, but let's take those referential dimensions, and we talk about it internally as an eventual consistency rather than a upfront consistency. But take some of those referential dimensions, link them, create the connections, and that knowledge graph becomes a way and a mechanism to connect the data across the divisions. And the value is we can now create new product, right? And the product that we're supporting with that incidentally, that's also how some of the open data stuff starts to appear, because if you're loading some of that thing, some of those referential data into a knowledge graph, you can take slices of that and say, this is actually stuff we want to share with customers. So to me, it's all about you have to be able to describe to your business partners, to the CFO, the value that you're delivering here, whether that's cost saving or whether that's new revenue.
I have to say that, one of the, people ask me uh, when I'm mentoring, what is one lesson? And I always say the one lesson I always want to pass forward is that any room you walk in, make sure you think about the value.
Yeah.
And I know I'm going to repeat that for technology because I think technology is a resource. If you can't produce value, that becomes a hobby. That becomes something that you're working with, but not really be able to produce value. So that becomes your science project. So
Yeah.
as an engineer, it's so important to think about when you are deploying a technology, which is just a resource for business, can we actually produce value? And if you can't produce value, you become irrelevant, And so always think about that, and especially in this day and age where, budgets are getting constrained, really need to think about, do we bring value where we are in the organization or in, your own project. And I think that leads to the leadership question,
Yeah.
in this age. Uh, Listen, I'm so fascinated, over the last 3 years after I wrote my first two books on the AI factor. I was so fascinated with the agentic world we are walking into, and the digital human. And my book is called The Digital Human Advantage. And the reason I spoke about or wrote that book was because we are going to be living in the world where we're going to have coworkers who are going to be digital human. We are very fast moving towards the agentic future. And as you look forward to this future, if you're building an enterprise data organization from scratch today, and especially from where you come, Dan,
Yeah.
of understanding the value of data and knowing what AI agents will, how increasingly will be consumed or how they will act with information. Uh, what are the critical pieces of architecture, 5 years from now, to distinguish your organization, to make sure that you're advanced data organization from everyone else, what recommendation or tips would you share with the
Yeah,
audience?
yeah. So no, this is spot on, and it's interesting. You mentioned the science projects earlier, and the fun thing about the science projects, if you're an engineer now, you can have the AI do a lot of the science project for you. And to both prove to myself and to my team this was true, 6 months ago, I started coding again in C++, which I hadn't done for 25 years. And I did it because I wanted to demonstrate to myself that the AI was good enough. C++ is not an easy language to work with. And, so I'm up and running with that. And increasingly, that GitHub Copilot, Claude Code, it's like having an intern. And I am actually describing the value that I want, the feature that I want to add, and it's going off and doing all of that engineering and software development for me. And if you look at that transformation that's happening in software engineering, I think that points the way to part of your answer, Asha. Um, the transformation, and it's important every leader really has a good understanding of what's going on with software engineering right now. The transformation that's occurring is we're moving to a point where increasingly none of us are going to look at the source code. In the same way that none of us look at the machine code that comes out the back of the compilers,
Yeah.
we're going to another level of abstraction. And that means that we're going to be both challenged as engineers to not work the way we were working. But it also means we need to get far better back to our conversation of value, just talking about what it is we're trying to get done and helping a machine understand that. Now, why has software engineering gone so quickly in that way? My argument, my suspicion is for two reasons. One, the output of a software engineer's job is objectively testable with unit tests, with does the code compile, all of those things. So we have a very quick cycling loop on being able to prove that the work that's being done is correct. The second is we have these wonderful multi-user configuration management tools like GitHub, or Git is actually the technology, right, that
Yes,
allow us to collaborate in a very scalable way. And when AI or the human makes a mistake, we can not only see the difference, the diffs, but we can unwind that mistake so we can go back to a known good state. So the question for me is, if those are the two things which are really enabling the software engineering industry to change so quickly and agentify, if you like, so quickly, and to your, to the thesis of your book, right? That's how the humans go to the next level. What does that look like for associated domains? So for data engineering, test-driven development has always been a poor cousin. We're not as mature yet in data engineering, how we test our work, how we rapidly cycle, how we version. So to me, software engineering points the way of where we're going. And now the challenge, and to your question about 5 years from now, what are the infrastructural pieces? Figure out how you're going to test all your work. Figure out how that testing is going to be objective. Figure out how you're going to have quick cycling on that. And I think the organizations that build their data pipelines, build their data infrastructure using some of those software engineering things, which are allowing that quick iteration, are the ones that are going to be able to move much quicker in the future. And then beyond there, we have to figure out what that means for attorneys and what that means for marketing people and
true.
uh, folks in finance. But let's solve it for data engineering because it's so close to software engineering already.
Absolutely. And I think you see the immediate results, and being the data
Mhm.
engineers who are on LinkedIn and listening to our podcast are the ones who actually understand the value for them to be able to adopt that and see the value makes so much sense. Dan, thank you so much for the grounded and forward. I would say that we've had the balance of being grounded and also forward-looking discussion. Tons of great tidbits, but mainly what stands out to me is the idea of the future of AI. It's not just working on experiment alone, building your science experiments, but really having the discipline. And I love what you've done in S&P Global, the creating the metadata, the interoperability, the
Yep,
governance, the architecture. I think these are not just the back office concerns. These are going to become competitive advantages. And I also think, as you mentioned, the organizations that succeed are not won't just deploy AI. They will build the infrastructure that will allow, the intelligence to operate safely. And in Wilda, we talk about really transparent, responsible, ethical AI, which we can
yep,
scale.
yes,
It's really about scaling. So Dan, thank you so much for being here.
of
And
course.
thank you everyone who joined us today. Thank you for being the part of this conversation. Thank you for being a part of Wilda. I know there are a lot of Wilda members who are listening to us. You all will we will continue these discussions. We will continue having this conversation that will create curiosity, make us lifelong learner. I always say we're living in this world that we have to invest in ourselves. We have to invest in learning and playing with this tool, not sitting on the sideline, and especially because we are here as the digital tech AI leaders. It becomes so important for us to continue having these conversations. If you have questions, if you have thoughts, feel free to reach out to Dan or me and continue sharing what you would like to hear, what you are worried about, what you want to think about and talk about. And we will make sure that we continue bringing these conversations to you. Thank you, everyone, and we look forward to seeing you in the next AI talk show. Thank you.
Thank you.